Yo, what's up guys? Welcome back. Patrick here. Moving on to another word problem. So we're told that it is 600 kilometers from town A to town B, and we're told that John leaves town A and heads to town B at 1 p.m. and drives 100 kilometers per hour. On the same day, Matt leaves town B at 2:30 p.m. and drives to town A at 80 kilometers per hour. And then they're asking at what time do they cross paths on the highway, and then how far from each town are they when they cross paths. So what I'm going to do is I'm first going to show this in a diagram. So let's say that this point here is town A, this point here is town B, and the distance between them is this 600 kilometers. So what we're told is that John leaves town A and heads to town B, so drives this way, at 1 p.m., so that's when he starts driving, and then drives at 100 kilometers per hour. So notice that at any time, we can actually create an expression for the distance that John drove at. So distance, we know just in general is equal to speed times time. And the speed at which John is driving is 100 kilometers per hour. But then what's this time here going to be? Well, we can introduce a new variable and we can say x equals the number of hours after 1 p.m. And then this would be x over here. Right, so let's say that, because that's when John starts, so let's say that John's been driving for an hour. What time would it be? It would be 2 p.m. and it would be 1 hour after 1 p.m. So we would plug in 1 here, so then the distance he drove after 1 hour is 100 times 1, which is 100 kilometers. Or let's say it's 3 p.m., then the x value would be 2. Plug in 2 here, he drove 200 kilometers. So the distance at any time, at any number of hours after 1 p.m. that John drove is going to equal 100x. That's the expression for the distance that John has driven. Now, on the same day, we're also told that Matt leaves town B at 2:30 p.m. So he leaves an hour and a half after John. He's leaving town B, and he's driving to town A at 80 kilometers per hour. So we can also create a distance, which is speed times time. We could create a distance expression for Matt. So his speed, we know, is 80. And then let's introduce a new variable here. We'll let y be the number of hours after 2:30 p.m. If y is the number of hours after 2:30 p.m., then the time, this time is the total time that Matt has driven, would just be y. So for example, if it's 4 o'clock p.m., that would be 1.5 hours after 2:30, so the y value would be 1.5, and we plug in 1.5 here, 80 times 1.5 would be 120. So at 4 p.m., Matt's been driving for an hour and a half. The distance that he's covered is 120 kilometers, right? So this here would be 80y. Like that. Now, when Matt and John cross paths, so if we extend this a bit, let's extend it to there. Just because John, he's driving at a faster speed and he started earlier, so obviously the distance is going to be greater that John covered versus the distance that Matt covered, and you could see it. It's not maybe to scale, but this distance is greater than this distance. Now, when they pass each other, note what does this distance and this distance have to add up to. It's got to add up to the distance between the towns. So we can say that 100x plus 80y equals 600, like that. Right? Because when they pass each other, we know this total distance is 600. So that means when they're passing each other, that means this distance plus that distance has to equal that total distance between the towns, 600. But notice that this equation here, it's in terms of two variables. So we can't solve for anything right now. So what we need is another equation in terms of x and y to relate them another way. So then we're going to have two equations, two unknowns. And the way we can do that is notice that x and y are always going to be an hour and a half apart. So let's make a column for x, let's make a column for y, and let's play around with some times. Let's say that it's 3 p.m. or let's say it's 4 p.m. Let's say it's 5 p.m. If it's 3 p.m., what's the value of x going to be? Number of hours after 1 p.m., it's going to be 2. If it's 3 p.m., what's the value of y going to be? The number of hours after 2:30, 0.5. If it's 4 p.m., what's the value of x going to be? The number of hours after 1 p.m., 3. The number of hours after 2:30 p.m., if it's 4 p.m., is going to be 1.5 hours. If it's 5 p.m., the number of hours after 1 p.m. is going to be 4. Number of hours after 2:30 p.m., if it's 5 p.m., is going to be 2.5. So notice the relationship here between x and y. Notice that x is always greater than y by 1.5 hours. Right? And that makes sense because between 1 and 2:30 is 1.5 hours, and x is the number of hours after 1 p.m., y is the number of hours after 2:30 p.m. So x is always going to be greater than y, and more specifically, x is always going to be y plus 1.5. Notice if we add 1.5 to all these values, we get the x values. So that there is our other equation. We could have also said x minus 1.5 equals y. That's another way. We could bring the 1.5 over. Or we could say x minus y equals 1.5. That's another way to represent it. So different ways you could represent it, but I'll just write x equals y plus 1.5. And now we have our two equations. We could just solve now. First thing I'm actually going to do is I'm going to divide both of these values, or I'm going to take the 100x plus 80y equals 600. And notice that we can divide everything by 20 to simplify. You don't necessarily have to, but I'm going to. So notice that 100 divided by 20 is 5. So 5x plus 4y equals 30. You don't necessarily have to do this step, but this equation, 5x plus 4y equals 30, is the exact same as 100x plus 80y equals 600. You could have also just solved from here, so you could plug in y plus 1.5 for this y value and then solve. But I'm going to use this one just because the numbers are a little nicer. So we'll have 5x plus 4y equals 30, like that. But again, it doesn't matter if you still kept the other equation with the larger numbers, you're still going to get the exact same answer. So from here, I'm going to do substitution. I'm going to plug in y plus 1.5 for this x value here, right? Because x equals y plus 1.5, so I'll have 5 bracket y plus 1.5 plus 4y equals 30. So we'll have 5y plus 5 times 1.5 is 7.5 plus 4y equals 30. This would end up being 9y, 5y plus 4y. Bring the 7.5 over, and we'll have 22.5 on the right side, right? 30 minus 7.5 is 22.5. And then we could divide both sides by 9. And when we do that, we we get y equaling 2.5, like that. And since x equals y plus 1.5, we know x would be 4. Right? Those are the values. And so now we can answer the question, at what time do they cross paths on the highway? Well, x is 4, so 4 hours after 1 p.m., which is 5 p.m. Or 2.5 hours after 2:30 p.m., which is also 5 p.m. So whichever one we plug in, we get that same time of 5 p.m. So that's the answer to the first question. And then how far from each town are they? Well, we can just take the x value of 4, plug it in here. So 100 times 4 would give us 400 kilometers. So when they cross paths, they're 400 kilometers away from town A. And then we could plug in 2.5 for the 80. 80 times 2.5 would give us 200. And then they're 200 kilometers away from town B. So this, and that are the answers. And notice that 400 plus 200 does indeed give us 600, the distance between the towns. Right? So they cross paths on the highway at 5 p.m. They're 200 kilometers away from town B when they cross paths, and they're 400 kilometers away from town A when they cross paths.